Let's go over Leetcode Weekly Contest 456. The first problem is partition string. We're given a string S and we want to partition it into segments where each segment has not been seen before. And at each step, we want to extend the segment until it becomes unique, then restart the process from the next character. The solution is to simulate with two pointers and use a set to track seen substrings. A try can also be used to optimize the time and space further as well. The next problem is longest common prefix between adjacent strings after removals. The problem states, for each index I, remove words I from the array and compute the maximum length of the longest common prefix among all adjacent string pairs. So for the solution, this is very similar to the product of array except self problem. For each I, the answer is simply the max of three cases. The prefix max, LCP, from 0 to I minus 1, the suffix max LCP from I plus 1 to n minus 1, and the LCP of the words I minus 1 and I plus 1. This leads to an O of n time and space solution, which can be optimized to O of 1 space with multiple passes. The next problem is partition array to minimize XOR. We're given an array nums and an integer k, and we want to partition nums into k non-empty subarrays and return the minimum possible value of the maximum XOR across all subarrays. We can use an O of n squared k dp. Since XOR doesn't behave monotonically, greedy binary search won't work well. So we can define dp of I, k as the minimum possible max XOR of partitioning nums starting from index I into k parts. We simply try every split point. We can define dp of I, k as the minimum of the max of the XOR, the subarray XOR from I, index I to j, and the dp of j plus 1, comma, k minus 1, right, over all split points j, where j ranges from index I to n minus 1. Now the last problem is maximizing spanning tree stability with upgrades. So we're given a graph with must and optional edges, and we want to return the maximum possible stability, which is the min edge strength in a tree, using at most k upgrades. And we want to return -1 if no spanning tree exists. So the solution idea is to use Kruskal's algorithm with union find. Clearly, all must equals 1 edges must be used, and optional edges can be upgraded up to a maximum of k times. And we want to use binary search